Okay, we are still talking about inverses here. So I want you to take a peek and look at this definition that's written here. And again, notice that it says on the study guide, in your own words. So you don't need to write this exactly how I have it. After our conversations over the last two studies, what do you guys think you would say that the definition of inverse is? So here we have written a function or relation that undoes the work of another function or relation. The input of a relation is the same as the output of its inverse. The domain of a function is the range of its inverse and vice versa. So remember that we're talking about a change in perspective. We're talking about what was once a horizontal shift is now moving to a vertical shift. What was once a vertical shift is now switching to a horizontal shift, etc. I really like to think of it as a change in perspective. Okay, let's go down here and see what fill in the blanks we're talking about. An inverse is a function or relation that undoes the work of another function or relation. What do I mean? I mean, as we were doing those little practice tables where I told you, okay, well, what's happening to x in the first function? Let's say that x is multiplying by 2 and then subtracting 3. And then we undo that work by adding 3 and multiplying by a half to get the inverse. So keep in mind that I'm talking about this inverse function is undoing the work of what was done right here in the first function. So that's what we're referencing here when we say that it undoes the work of another function. If a function adds 3, its inverse will subtract 3. In function notation, the inverse of f of x is written as the domain of the function is the range of its inverse, and the range of a function is the domain of its inverse. The inputs of the function are now the outputs, and then the outputs become the inputs. We are switching x and y. It's a change in perspective. Okay, write x or y in the blank to show the rule. So to find an ordered pair of the function's inverse, we just switch the x and y coordinate. So originally we had x and y here. The inverse is just switching that. It now becomes y, comma, x. All right, here we go. Let's write actual steps out of what we've practiced already for 2 days in our class. Step 1, if you recall, is to replace f of x with y. Notice how we're getting the formal steps written out now in this study guide. Step 2 is to switch the x and the y. Oops. Step 3 is to solve for y. And remember that I then switch it around and I write it as a y equals in front. And finally, replace y with the inverse notation of f of negative 1 of x. Now let's take a quick peek at the shortcut I taught you guys. What's happening to our x function? 3 is adding to it. What's the opposite of 3? 3 being subtracted. So take a peek at my inverse, how it's the opposite. How do I undo a plus 3? I minus 3. Now we don't need to have this table here right in the middle of the thing. I just wanted to kind of quickly show you that shortcut. All right, let's go see the next section. To find the inverse of any function, take the original equation and solve for the input variable. So in this next example, it's not an x and a y. It's a p and an S. But we have to know that we're looking to make the independent right here, the input variable, right? So what would be an X? What the S in this case? So here I start by same first step, making it equal to P. Step 2 is to replace the function name with the output and then switch them. And then we switch the last step back into the opposite notation. Again, a difference in perspective. P of S is now S of P, and that's equal to P minus 3 over 2. So this use of different letters instead of X and F of X, I want us to realize that this can happen. We can have different input and output variables besides an X and a Y, or an X and an F of X. The function C of F is equal to this, convert degree Fahrenheit to degrees Celsius. Like, what if I'm solving one variable versus solving for the other? I have Celsius, I want Fahrenheit. I have Fahrenheit, I want Celsius. So based on that difference in perspective, I want to switch this equation around for the other one. Sorry, I'm looking, where should we show the work here? I guess we'll put it on this one. So starting with the original equation, we're going to try to solve backwards for this F. I want it to be an F equals instead of the C equals. So what would I do first in order to isolate the F? We need to get rid of the 5/9. So I'm going to go multiply by the reciprocal to both sides, times 9/5 times 9/5. Why do we multiply by the reciprocal? So that we can cross that out. Now I've got 9/5 C equals F minus 32. I just need to move the 32 over. So now I've got my new function in terms of Fahrenheit. And so you can rewrite it as F of C if you'd like to, as a function name. F of C equals 9/5 C plus 32. Again, what did I just do? I changed the perspective, meaning what if I have Celsius and want Fahrenheit? Up here, what if I had Fahrenheit and I want to solve for Celsius? But I wanted to change the perspective. What if I want to plug in a Celsius to get a Fahrenheit? So this idea of inverses is really something we do in real life all the time. It just depends on our vantage point. What do we have and what do we want? And sometimes that can be opposite of what someone else has and what they want. And so we are able to manipulate this entire equation and make it into a new equation, pretty much known as the opposite or the inverse, where it's really just a new perspective. It's going for a different variable than someone else might be going for. Hope that helps with the real life connection there.